In this video, we will look at an aspect of circle geometry. I will attempt to prove a theorem. The theorem states that the angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc on the circumference of a circle. Basically, this means that the angle that is at the center of the circle is A. This angle at the center of a circle is twice the value of the angle at the circumference of the circle. If we go over a bit of circle terminology, the circumference of a circle is the distance around the circle, and an arc is a portion of the circumference. And the word subtended means to form or to create. So this angle at the center of the circle, angle 2 alpha, is subtended or formed by the arc CB. Arc CB also subtends the angle that's at the circumference of the circle. This angle is subtended by arc CB. So we need to prove that this angle at the center of the circle is twice the value of this angle at the circumference of the circle. Before we move on to the proofs, there's some theory that we need to know. So, if we have a triangle that has an exterior angle, so this is the exterior angle. This angle is equal to the sum of the two opposite interior angles of the triangle. So that angle is equal to this angle plus that angle, okay? And something else that we need to know is that when we have a triangle that has two sides that are equal to each other, it's called an isosceles triangle, and the base angles of this triangle are equal to each other. So that's just a little bit of revision. Okay, now for the proof. A is the center of the circle with arc CB subtending the angle at the center of the circle, and it also subtends the angle at the circumference of the circle. We need to prove that the angle at the center of the circle is twice the value of the angle at the circumference. The first thing we need to do is construct a line from the point on the circumference to the center of the circle and extend it through to E. Triangle ACD has an exterior angle, that is angle beta. We have said that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So we can say that beta is equal to theta plus delta. So because beta is the exterior angle of triangle ACD, it is equal to the sum of the two opposite interior angles, which is theta and delta. Beta is equal to theta plus delta. Then if we look at triangle ABD, alpha is the exterior angle of triangle ABD, and that means that this angle is equal to the sum of the two opposite interior angles of this triangle. The two opposite interior angles are omega and psi. So alpha is equal to omega plus psi. Okay? If we look at line AD, line AB, and line AC, all three of them are radii. They are radii of the circle, so that means that all of them have the same length. So we can say that if all of them have the same length, then triangle ACD is a triangle that has two sides that are equal to each other, so it's an isosceles triangle. With an isosceles triangle, we said that the base angles are equal to each other. So we are saying that delta is equal to theta. Okay? Then if we look at triangle ABD, it's also an isosceles triangle because AB is equal to AD. So the base angles of this triangle are equal to each other. So this angle omega is equal to psi. So we've said that beta is equal to theta plus delta, and we've also said that theta and delta have the same value. So we can say that beta is therefore equal to 2 theta. Okay, and we also said that alpha is equal to omega plus psi, and since psi and omega are the same, have the same value, alpha is equal to 2 times omega. Alpha and beta, they're at the center of the circle, and alpha and beta together make up the angle that is at the center of the circle. So we can add alpha and beta and say that that's the center of the angle at the center of the circle. And the value of alpha is 2 omega, the value of beta is 2 theta. So alpha plus beta is equal to 2 theta plus 2 omega. Okay, now 2 is common in both terms, 2 theta plus 2 omega. So we can use algebra and factorize the 2 out. So we can say that alpha plus beta is equal to 2 theta plus omega. Now, alpha plus beta is the angle at the center of the circle, and theta plus omega is the angle that is at the circumference of the circle. So, this expression basically says that alpha plus beta, which is at the center of the circle, is 2 times the value of alpha plus omega, which is at the circumference of the circle. So we have proved the theorem that states that the angle at the center of the circle is 2 times the angle at the circumference of the circle.